This video will cover reading delimited text files into R. The code used in this video is available on the Learning Management System. We'll use two data files in this video, College Park Weather 2017.csv and College Park Weather 2017.txt. You should download these data files if you'd like to follow along. By the end of this video, you should know what a delimited text file is and how you might load data from a delimited text file into R. There are many file formats that are used to transmit data between data processing systems. One broad class of those files are text files. While the text is human readable, it might be difficult to parse the data out of these files. Text data files require your data analysis program to make informed guesses about what separates each variable and each observation of the data and the data type of each variable. Remember, R and other data processing software are going to convert data into tidy data, and having this information ahead of time is essential to creating a tidy data set. So why do we actually use text files to transmit data? They have several advantages. First of all, they're human readable. You can open up a text file with Notepad or another text file editor and actually read the data out of it. They also have a very simple format. Most software has functions for dealing with text files, and the rules for reading data aren't very complicated, and they're very easy to program. As a result, text files have become more or less a standard for sharing data. There are some big disadvantages to text files, which means they're not ideal in every situation. Importantly, you're generally transmitting numeric data in these files, and numbers are not text. So your data processing software, while reading text files, will generally need to guess the data type in each variable. Guessing data types is very slow. And importantly, guesses can be wrong. If your software guesses wrong, that means you have to make manual adjustments, which makes you work more. Also, the actual process of converting text data into the computer representation is slow, and storing numbers as text introduces imprecision. It may not include as many decimal places in the text file as the computer actually stores, or there might be slight differences in the base 10 representation in the text file versus the base 2 representation that your computer uses. On top of that, text files are bulky. There's no such thing as a factor data type. Whenever you have textual data, the full piece of textual data needs to be stored in the text file. That can make these files really large. Lastly, there are many dialects of text files. These are different ways of separating observations and variables, and getting all of this information right is essential to reading a text file properly. There are several different ways of storing data in text files. The primary method are delimited text files. Reading delimited text files are what's covered in this video. A delimited text file is going to store data in a text file. Each observation is going to be one line of that text file, and each variable in an observation is going to be separated by a delimiter. A delimiter is a special character that your data processing software knows separates variables. This is the most common type of text data file. Among delimited text files, the most common is the comma-separated value file, or CSV. Again, observations in comma-separated value files are terminated by a new line, so there's one observation per line of data. Variables are delimited or separated by commas. Frequently, text might be put in quotes. That's not always the case. The first row of the file usually, but not always, contains variable names. Those files are usually going to have the extension .csv. There's a tidyverse function for reading these files, which is read_CSV. So I have here an example of what a comma-separated value file might look like if you opened it up in Notepad. And what you can see is in the first row, you have variable names. Each one is separated by a column. And then in each subsequent row, you have observations of data with commas separating the various values. Data readers, like the read_CSV function, can process these files and create a tidy data set, knowing the proper variable names, which observation is which, and which value corresponds to which variable for each observation. Let's work through an example of loading a CSV file in R. First, I'm going to run some setup code. We're going to refer to this CSV file several times, so rather than type out the file name every time, I'm going to save the combination of the path to that file and the file name in a variable called csv.file. I do that here. Now that I've done that, we can try and read that file into a table of data that I'll call weather. I do that on line 25. I'll run that code. So you can see there was some output in the output window. In the Environment Explorer in the upper right-hand corner, I have a new variable, weather, which contains 8,409 observations and 6 variables. I can take a look at the contents using the print function. Again, you can see here that I have 6 variables, a variable called x1, a variable called date, then day of week, hour, temp C, and RH. The corresponding data types are in the next row, and then there's some sample data below. That read CSV function was able to successfully load data from the CSV file. It may not always go that well for you. There are some problems you can encounter. For example, what if your data has commas inside of it? How can R tell the difference between commas that are data and commas that should be delimiting variables? There are also many different rules for how quotation marks might be handled in your data. Lastly, it's not an issue with R, but some other data processing systems might get tripped up by the fact that Windows, Macs, and Linux all have different ways of ending lines. And in other data processing systems, if you're not precise about this, you may not get the results you expect. A second common type of delimited text file is a tab-separated value file. These are very similar to comma-separated value files, except instead of using the comma delimiter, they use the tab character instead. Tab-separated value files usually have extensions of .txt or .tsv. Not every .txt file is a tab-separated value file, but it's frequently an extension associated with tab-separated value files. Tab-separated value files solve the problem, what if there's commas in my data? Because now the tab is the delimiter instead of the comma. This comes at the cost of a new problem. What if you have tabs in your data? So, other than the change in delimiter, this file type has the exact same advantages and disadvantages as a CSV file. They're not quite as common as CSV files. R has a function for reading these, and that's called read_TSV. So we can also work through an example of loading a TSV file. Once again, I'm going to save the full path to my TSV file in a variable called tsv.file. I do that here. Then I can read that TSV file into R using the readTSV function. But let's see what happens if instead I made the mistake and tried to load it with readCSV. I'll do that. You'll notice there's a bunch of error messages in the output window. And if I print that tibble out, you can see that I get a very odd message. This is because R attempted to read this TSV file, thinking that commas were the delimiter, and so it wasn't able to read it correctly. Let's read the file correctly using the readTSV function. I'll run that bit of code here. You see I get far less output in the console window. Let's take a look at the tibble that was loaded, weather.tsv. And you can see that R has loaded the dataset correctly. Sometimes you'll encounter delimited text files that use things other than commas or tabs to delimit values. Often these files have .txt extensions, but they could be anything. Changing the delimiter to something else solves the what if I have commas and tabs in my data problem, but that comes at the cost of a new problem that you specified a different character as a delimiter, and what if your data contains that character as well? Again, otherwise these have the same advantages and disadvantages as CSV and TSV files. There are many different formats of delimited text files, so it's important to take time to understand what you have before you try loading it. You can load text files with arbitrary delimiters using the readDelim function. ReadDelim behaves exactly the same as readCSV and readTSV. You just need to tell it what the delimiter is. So you can think of CSVs and TSVs as just special cases of the readDelim function. CSVs and TSVs are just special cases of delimited files, and so you can read both of them using the readDelim function. ReadDelim works exactly the same as the readCSV and readTSV functions, except you provide an additional named argument, delim equal to, and then you put the delimiter in quotation marks. So in this first example, I'll load the CSV file using readDelim, but I explicitly set the delimiter as a comma. I'll run that. Since I didn't save the result to a variable, it prints out in the console window, and you can see I get something very similar to what I got in the past. I can do the exact same thing with a tab-separated value file. You tell R that the delimiter is a tab using the special sequence of a backslash and a T. That's what I have here. I'll run that. Once again, I didn't save it to a variable, and you can see the resulting tibble looks very much like it's loaded correctly. There are some important things to know about the mechanics of reading delimited text files. Generally, the first row of a delimited text file will contain the column names. The tidyverse data readers are always going to keep the column names as is, but if they contain illegal characters, characters that can't be used in R variable names, they're going to use backticks around the name of the variable. So in this example, the variable name, this name has spaces. The space is an illegal character, so what R does is it encloses that variable name in backticks. It's also important to remember that text files are not R data. So when looking at your text file before loading it, you should be sure to note whether or not the text file actually contains variable names, what row the data start on, Text files don't contain information about the data types in each column, so you may need to provide this information to R. Likewise, if there's quotation marks in your file, it's not always clear to R how to handle those quotation marks. Lastly, there's no standard for how missing values should be treated in text files. There are many different special ways of representing missing values depending on which software created the text file, so you might need to tell R which values need to be changed to NA. Read-delim and the special case versions of this function make guesses about some of these based on the content of the file. As a warning, guessing takes time, but more importantly, for large files, memory could be a bigger issue than time. By default, read-delim is going to base its guess on the first 1,000 rows of data. If you have errors reading the file, the easiest thing to do is increase the number of rows that it looks at by changing the guess max argument. You can specify any number, and R will process that many rows before it tries to decide what the data type in each column is. That doesn't always work, and sometimes you need to manually specify column types. You do that using the col types argument. How does col types work in R? You provide a special argument to read-delim called col_types. You set it equal to the cols function, and then you provide a list of all the columns, and then specifiers to tell R which data type to use for that column. When R reads the file, it will force the data in that column to be of the specified data type. If R is unable to convert it to the specified data type, it's going to give you a missing instead. This syntax seems a little complicated over here, but you should note that if you use read-delim without any col types arguments, R actually prints out the col type specification that it creates by guessing. And you can see that here from the last TSV file we loaded. R had to guess the column types, and it shows them in the output window. So how precisely do these col type specifications work? Again, first, you'll say col types equals cols, and then inside the parentheses, you'll provide specifications for each column. So here I say the month column should be of type col integer, which says it's an integer value. And what you can see is R will look for the month variable name and treat every value as an integer. Likewise, the same for day. It will look for the day variable and treat every value in that column as an integer. Here, the measurement column is col character. R will look for that column and treat every value as character data. And then lastly, the level column will be treated as a double. There are many different column data types. I show them in this table here. Col logical is for true false values. Integer, double, and character we saw in the previous example. Col factor is for text as factors. Col date and col date time are designed for reading dates and combinations of dates plus time. Likewise, col time is for reading time-only data. Col guess tells R to look at that column and guess the data type. And finally, col skip tells R not to load the data in that column. You don't need to specify every column in a col types function. If you use .default and set that to a column type, R is going to use that data type for every column whose type you don't explicitly specify. And a reminder, if you run read-delim without specifying col types, it will print out the col specification that it used as the warning message. There are some other common options to these readers as well. Col_names, if you set to true, will read the first row of data as variable names. This is the default behavior. If you specify false, it's not going to use variable names and will create its own variable names for every column. Lastly, you can provide a vector of names that you want it to give to all of the variables in your data set. The NA option provides a vector of string values that will be converted to NAs. So in this example here, I say NA is equal to C, and then I provide the empty string, 2 quotation marks right next to each other, NA in quotation marks, and then hashtag value with an exclamation point afterwards. Anytime R encounters any of these, an empty value, NA, or hashtag value, it's going to convert that to NA when it loads the data. The skip option tells R to skip a set number of lines before it starts trying to read data. This is useful if there's header information in your file. And lastly, n_max tells R the maximum number of rows to read. Generally, you want to read all of your data file. You can specify the nmax function to force R to stop reading files as you're still playing around trying to get your specification correct, and that way you don't have to sit and wait for R to process the entire data file. There are a lot of options here. The nice thing about using these tidyverse data readers is these options work the exact same way across all of the other file readers that we'll cover in the subsequent videos.